So our next talk will be held by Sai Dasari, and he will be talking about BMC hardware and the OpenBMC software. So give an applause for Sai Dasari.
Thank you. Can you hear me? Okay. Yeah, welcome to the last session of today, which is OpenBMC. My name is Sai. OpenBMC is the open source system management firmware stack. How many of you have heard of BMC? Wow, that makes my life easy. I have prepared a lot for the people who doesn't know about BMC, so I just prepared some use cases. But anyway, I'm going to go over them. So we have why BMC and what it helps in the data center is my first half of the talk. And then we look at how do we implement the BMC firmware stack, what has been happening in the last 20 years, and then what we did in the last 4 years. So when you look at this scale-out data centers, so they look like this on the picture. Just one aisle that has a bunch of racks. Each rack has either compute servers, storage systems, and the top of the rack switch. All of these are systems. And you can imagine these kind of rows being in the data center. About like a football field is what they call like each buildings. That kind of buildings are about like 4 per each site. And these kind of data centers are across world, pretty much like remote. So why should we manage them continuously? So one reason is like say these are all running 24/7 services. So it means like not unlike like enterprise systems where you have morning to evening and then you have less loaded time. These services are running like 24/7, and we need any kind of failure that happens at this scale is going to be like needing a lot of people to run around, fix them. So we'd like to kind of do a lot of autonomous remediation, like autonomously be able to fix issues, detect issues, and then fix them. So that's the goal for managing the systems at remote. So I'll show you some use cases actually. What do I mean by system management? What kind of use cases exist for the scale-out data centers? Because this concept is not new. It has been there for the last 20 years. But most typically they emphasize like a single system management versus like say, what kind of use cases are there for a bigger, larger scale systems? The first use case I take is the inventory information. So these days the complex systems are not like built as a monolithic one system. So it is built out of like multiple components so that we can easy to replace. So if something goes wrong for one component, it's called FRU, field replaceable units. So we can replace that component with another one. So what's the problem here? So when we build or assemble the systems, we scan all those serial numbers, part numbers, etc., put it in the database. And when somebody has to kind of replace a component, they go there, take out the bad FRU, put the new one, scan the new entry, that updates the database. But since there are human errors, always things go wrong. Sometimes people forget to kind of do that as part of the repair process. Or in other cases, as part of debugging, people swap the components and then it's not considered as a repair process. So we have wrong data in the database. So when somebody looks at the database, they see a FRU which is not supposed to be there, or they still think that FRU is bad. So this is one use case where we would like to kind of audit entire data center and find out like say what components are we using, what kind of FRUs are they really operational in the field. So this is one use case I would like to bring, saying that having that information real time and accurate is very important. Power. So you can pay a lot of money, but you don't get power for the data centers. So we have a very tight limit or budget on data centers, how much power we can use. So anytime, any savings that we can do in the power is automatically translated into their money. And then this way, we would like to kind of have the power on systems that we really want to have them. And if we don't use them, just power it off, shut it down. That capability we need remotely. And the other thing is the new modern CPUs, they can operate at wide range of powers. Like they can start with 20 watts power with less performance, all the way to 100 watts in some cases, beyond that. So we have ability to kind of tune that power need based on the workload. So this is another feature that we would like to have from remotely. The third one is system monitoring. So nowadays the hardware is pretty stable and very reliable compared to the hardware that we used to have 20 years back. But still things go wrong once in a while, like the voltage is going out of fluctuation, or like temperatures going out of the operating range. So we need a way to kind of monitor them continuously, 24/7, all the signals like voltages, power, temperature, or etc. So or critical signals using GPIOs. And in some cases, when we see something going wrong or like in a wrong direction, like temperature, for example, we can control fans and then make sure that it is cooled down. In some other cases, the failure could be fatal. In that case, all we can do is log them and then send it out for the technician to kind of debug it. So these are the two use cases that we have for monitoring systems continuously. So we need a kind of autonomous system to kind of monitor the hardware continuously. Debug. So when things go wrong in the servers, the way we debug is typically if it is accessible, the system is accessible, you log into the system, look at the logs from the application or the operating system and find out what happened actually. What is the problem with that particular application or the operating system? But in some cases, the whole kernel is hung. In that case, other than serial console, we don't have any other way to debug it. So this is one reason why we want to have a remote way to connect to the host and get the serial console and see what happens. In some cases, like say if kernel is hung, even if you connect to the console, you cannot get any information on that. So in that case, we would like to see what happened before, before the failure. Maybe there is a stack trace that I can take a look and then identify the bug. So we need to kind of have a history of the remote console. Firmware update. So we have a lot of firmware components, like these systems are so sophisticated nowadays. As today morning somebody was saying, other than resistor, everything else is programmable. You can see here the programmable components that we use today. The CPLDs, voltage regulators, the BIOS, BMC, network, NIC cards, the SATA, you name any component, it's upgradable. So we would like to upgrade them remotely. So this is another use case we have for managing systems remotely. So for all of this, like what solution? This is nothing new, actually. It has been there for 20 years. So we add an autonomous system called BMC. So BMC is the baseboard management controller. It's autonomous, means it has its own CPU, its own memory, DDR4, and its own storage, means like we can store logs. And it's totally isolated from the power point of view. So that way it's always running. Even if you want to save power, you can power off entire system, but you still run BMC. So it provides you remote access to that. So that's why I think the bottom highlighted part is the BMC, small subsystem. It doesn't take any power, like compared to the regular power that we mentioned before, to sub 1 watt. And then the cost of adding it also pretty low compared to any typical server or like storage system. So overhead-wise, it's not much, but the benefits it gives us is having all this access to these remote services, remote control services. So the previous slide shows like how a BMC can help us manage one system at a time. So in this use case, we have the outside you can see in our booth, there is 4 servers in a single chassis. We call it as a sled that has 4 independent servers. And they are all controlled by one BMC. So we call it as a multi-host system. So here you can see like the network card is shared with all the 4 servers and the power is shared. So it looks like a single box, but it has 4 independent servers in it. And back in the days, like the BMC itself used to be very small, like 8-bit microcontroller. And then like Renesas is one of the famous, like we used to use it. And then the code used to be like a pretty much like metal code. No operating system, nothing. But in the last decade, I think the BMC became so sophisticated. I think we started running real-time operating systems like VxWorks, Chorus, and other real-time OSS FreeRTOS. And now if you look at the BMCs, they are like running ARM core at 800 megahertz. And it has DDR4 controllers and then a bunch of other IOs. It looks to me like a decade back, if you take a laptop specs, it looks exactly like this. So I think BMCs have become so sophisticated that we can run Linux on it. So this is another standard controller, like a Pilot 4. This used to be a company called Emulex, and now it is owned by ASPEED. So this also you can see, it has dual ARM core running at 500 megahertz. It's pretty much like an A9 processor. So you can see the sophistication of the BMC chip itself. This is one more from Novoton. Again, dual core A9. So with these powerful BMCs, now we can address some of the advanced use cases. So I would go over like a couple of them. What are the advanced use cases in this case? The first one is like LCD debug card. So typically when there is a problem with the system, we used to have a small debug card that prints out that you can see the 8-segment LED code. So when system gets stuck in that place, operator can understand, okay, what is this code A9 means? They might know it's a DIM issue. They can go and replace it. But now that at scale, it's becoming very difficult actually, because now people have to remember like what the postcode means, what action to take. So instead of that, I think we came up with this LCD debug card, and then that has a user-friendly format. You can print strings. So instead of just having access to the code, now they know what has the real failure or what kind of logs, what is the temperature. So all the sensors, it prints out all the sensors. I have some slides to show. Here just a asterisk for the OCP, so just a plugin for the Open Compute project. So some of you might know, and then this is a Open Compute project. It is open source hardware, just like Linux is treated as open source kernel. So there is a community working on open source hardware. So that has networking, compute, storage, telco. I think a lot of subgroups working on different aspects of data center hardware. And this card is also like open source under that, so you can find the schematics for this and then build it for your use case. Why this is complicated? So the debug card itself has a small microcontroller in that, and then that is connected to the main board using USB signaling, and then that has a bunch of GPIO access and also the I2C. So we run IPMB protocol to kind of talk between BMC and the microcontroller to exchange information. Like the logs, sensors, everything is printed on the LCD debug card using the BMC. So this is the communication path. Some example debug pictures. On the left side, you can see the postcode. And on the left side, you can see previously we used to have just the postcode, like 67. But now we can, on the right side, you can see the LCD card that printing like what is the actual code means in a user readable format, as well as the what happened before actually. So you might miss the previous postcode. So now we have a chance to look at like what happened in the previous last 4 or 5 postcodes. Or more than that actually. We store about 16 postcodes in single page. And you can go back and forth between pages. The button that allows you to kind of go back and forth between various information you want to get. So on the left side you can see postcode, on the right side you can see GPIO status, like say proc hard kind of critical signals. Is there anything is wrong with the system? So on the left side you can see critical sensors, like what is the temperature sensor showing, what is the current status. On the right side, you can see the system information. All of these screens, you can just use the button, go to the next page, back and forth. The second major feature that I would like to enhance is the at-scale debug. So on the left side, you can see how we used to debug before. When there is an issue at the CPU level, if you identify at the bench top, we used to connect this kind of blue box. We call it as an Intel ITP box. And using a laptop, we can debug that code and understand what's happening. This model works kind of on the lab side when bringing up, but if the same issue happens at the scale, like one system out of 100,000 systems are showing this problem, it's pretty hard to kind of debug that issue. So we cannot reproduce it. We cannot connect any debug cables for all of the systems at the time. So the feature that Intel, thanks to Intel, I think they came up with this at-scale debug feature. So where BMC is used as a proxy, and then over the network, you send all the debug commands, and then BMC converts them into JTAG, and then run them. So now we have ability to kind of debug remotely using BMC as a proxy. The last one is about NIC card, so OCP NIC card. So if you look at our system that is on display, so this is a multi-host Yosemite system which has 4 individual servers and then BMC sharing one NIC. So the NIC supports multiple PCIe links so that each of them think they have their own NIC, but physically there's one cable that goes out of the box and provides connectivity to all 5 independent controllers on this side. So this is the same picture that I have shown before, but highlighting the OCP v2, the multi-host NIC mezzanine card. So it has evolved a little bit over the last few years. The version 1 used to support 10 gig, and then it has the I2C as a sideband for the BMC. It's kind of capped at 100 kbps link for the network connectivity for BMC. But in the 2.0 spec, I think we have bumped up to 100 gig support for the host. And for BMC, it goes up to 100 meg, because now we support NCSI over RMI signals. And 3.0 is currently under review, and then it is going through active discussions in the OCP. And it's not just Facebook that is using it, but there's industry-wide, there's a lot of companies that support this form factor, and then you can buy it from any of these companies actually. So I won't go into each individual detail, but pretty much like say, since the NIC is going to be the heart of connectivity to the system, and it can impact all 4 servers plus BMC, it's very important for us to monitor it continuously. Like if something goes wrong in this NIC, it's going to impact all the 4 servers. So you as well lost like 4 servers in the fleet. So we would like to monitor it like temperature and then control, and also update the firmware if some corruption happens, and then inventory, etc. And thanks to the DMTF, so we don't need to invent the protocols to talk between the BMC and the NIC. NIC is kind of made by so many vendors actually, so it's better to kind of have standards. So in this case, DMTF came up with the PMCI standard that has multiple protocols that allows us to kind of monitor it, update the firmware. All these protocols are well understood by the industry. So it's easy for BMC to kind of adapt to this. So with that, I think this is a use case for BMCs and why we need it, what kind of advanced use cases we can do with the advanced chips that we are getting for the BMC. And now we jump into like software part of it, the OpenBMC. As a little bit of history on this, so as I mentioned before, BMC has been there for 20 years. And every company has their own BMC team developing BMCs, or like use third-party companies to kind of buy the software, just modify it. But 4 years back when we looked at BMC software, for the timing's sake, I think the existing solution where we go to the third-party BMC and then get the solution was kind of time-consuming. So it was not suiting our bring-up needs. So we looked at like say, is there any open source alternative? We thought it's like 20 years. I think there should be somebody might be having an open source solution, but guess what? We couldn't find any single open source solution for this. So we took an approach of why don't we do it ourselves? So we took the BMC vendors SDK and then used Acto Linux BitBake as the build system, and then tried to create this BMC firmware, OpenBMC. Independently, like IBM at the same time, they were trying to do the Power 9 servers, and then they have entire firmware is open source except BMC. So now they were looking at is there any solution? So they found Facebook OpenBMC. We worked together, and then they started OpenBMC project. This happened about 2 to 3 years, in the last 3 years. So last year when we talked to other people like Intel, Microsoft, Google, everybody has their own need for OpenBMC, but everybody has their own efforts going in parallel. So we sat together for about 6 months and then thought, why don't we make it as a kind of community project? Instead of each of us kind of spending effort independently, why don't we come together, create one project under Linux Foundation, and then work together. So that's what happened in the last 1 year. Actually, this March is when I think we created this Linux Foundation project with these partners. So OpenBMC is like open source system management. It's a Linux distribution, and then it's a community project. And one of the goals is to kind of have a software and tooling to kind of see OpenBMC with a standard interfaces. So like Redfish is one of the emerging standard where we can always manage the systems seamlessly. And the last bullet talks about heterogeneous. So here heterogeneous means like type of systems. So in our case, we use like network switches, storage systems, compute servers. Everybody uses OpenBMC. It's nothing specific to a type of system. And other case, like we have BMC chips, which are supported, the system on chip. So one is ASpeed, the other one is like Nuvoton. They're also adding their stuff into the OpenBMC. So now we have two types of BMC controllers supported in the OpenBMC. And other heterogeneous part is like say x86 processors versus Power 9. I think the IBM systems, they use the Power 9 systems and they are managed by OpenBMC, whereas other companies use x86 and it's heterogeneous again. So just want to highlight the fact that OpenBMC can support any type of heterogeneous management. From the development model point of view, the left side is what we have been doing before. So we have the hardware vendors like ASpeed giving you the BMC chip, or like other hardwares, NIC and power supplies from other companies. So they give the SDK, and then we work with the third-party vendor and then ODM, and it's kind of flows through in a different ecosystem. There is no real ecosystem in the previous case. Whereas with OpenBMC, we would like to create that kind of ecosystem where all the people come together, like all the vendors, like BMC vendors, hardware vendors, the ODMs, and even x86 or Power 9 vendors coming together and then be part of this OpenBMC system and support for all types of hardware that is possible. Architecturally, I just simplified this diagram, but I think you can get a flavor of it. So it just has the hardware at the bottom, like you have BMC system on chip, and then the U-boot is our bootloader, then Yocto Linux, and the applications use the dbus as the IPC mechanisms. So this gives us a kind of namespace where we have multiple applications talk to each other using one single bus, and then there is no collision between namespaces. So getting started is pretty easy actually. There is a build setup is on the GitHub front page. And there is continuous integration testing happening on for subset of reference platforms. We are still working on it like to kind of add multiple platforms. And you can contribute either design specs or the code. And Gerrit is the place we use for code reviews. And any bugs can be reported through GitHub. So this is where it shows like the beauty of Yocto Linux, where you have multiple repos. We just have the kernel repo and then Acto and Open Embedded and the OpenBMC repos, which is split into multiple repos based on the features. And we use a simple bitbake file to put them together, point to the actual target, supported target, and then create the binary. So until like last couple of months back, every company used to kind of add features based on their need. So after we created this Linux Foundation project, now we have a planning subgroup where we kind of come up with our first planning for the next February 19. So where we kind of try to say like what are all the features we can get by the time frame. And then we are working on the milestones, like say what kind of code goes into like each milestone and track it. So this becomes like a little bit more formal, but with so many companies participating in the community, I think it's one way we can get things moving faster and then reduce like multiple people working on the same thing. I'm not going to go over all the features, so we identified some of these features as a higher priority for the next release. And some of them are like already in the GitHub, in the repo. Some of them are like in the design phase. Some of them are like almost getting done, the code review phase. And this is a backlog. So these features are like, there's nobody to work on it. There is no resources. So we put them as backlog for the next year. So it doesn't mean that somebody here who are interested in this feature can get started working on now. So there's a hackathon upcoming. Intel is hosting our second hackathon. There are details, I just put it up in case if some of you are planning to attend that. These are hackathon topics. Again, it's not limited. It's pretty much like community driven. So the mailing list has all the details. Like if you want to add a new hackathon topic, I think it's pretty welcome to use. And there's a bunch of community calls, like one is for the project, the others are for a project specific or like focus area, working on the planning or testing or on Redfish. So there is a subgroups working on each of these independent ones. So they meet once weekly to kind of share their status and then plan for the next event. There are a bunch of additional resources here. Where is the source code? Where does this continuous integration test happens? Code reviews, contact information, IRC channels, the main web page that connects all of them together. As the last slide, I would like to show how does OpenBMC fit into this ecosystem, like OCP ecosystem. So OCP is where I think people are coming together and then sharing their hardware designs, and then the designs have today, like when you look at the OCP design collateral, you have the schematics, specifications, presentations, even 3D CAD models, which allows you to kind of build entire server or storage system that we open source. But what it doesn't give today is like the firmware. So without the firmware, you cannot even boot up. Like say, where do I get my NIC firmware? Where do I get my BMC? Where do I get a BIOS? So that part is like kind of blank today. It's like nobody knows where to get it. People can build the hardware, but they don't have a way to get the software. So this is some active area that OCP is looking into. And we are trying to create a firmware as one of the design collateral. So what it means is like, it will be having a metadata to kind of either build firmware from sources or like download at least in cases where the open source is not available. So the bunch of options on the right side that I have shown, like one could be like a binary blob. Like FSP could be a good example, where since we cannot open source the code itself today, we can point to the FSP and say this is where you can download. Or it could be a pre-built binary as a binary blob. Or the other option is like say if somebody doesn't want to open source, but they still have the code in the company specific repo, we can still have a make file that goes there, pick it up and build it for that source, and then create a binary for that. Third option is, which is preferred, is kind of core boot, Linux boot, and OpenBMC kind of projects where you point to the platform and say, use this make file to kind of get this repo, build it for this platform. The last option is like say OCP itself could host its own GitHub repo specific to the projects or the features that are specific to OCP alone, which could not be many actually, but there are like say LED profiles or OCP redfish profiles. So they're very specific to OCP hardware. So in that case, I think it's better to kind of keep that under OCP because it might not be fitting into like general open source projects. But again, it does not prevent us to go only one route. There could be cases where we want to build a firmware from a set of binary blobs plus some company specific source code plus some open source project. So you can build all of them together. But the idea is from somebody coming to the OCP, they should be able to kind of build the firmware they need, find the firmware for the product. With that, I'm open up for questions.
Thank you very much. Give a round of applause for Sai Dasari. Wow, everyone finished up on time today. Yeah, we have time enough for questions, a lot of time actually. Okay, there are a lot of questions.
Hey, my name is Dimi, and I'm actually really glad to hear firsthand that the OpenBMC project is picking up the pace. It was going a bit slow, so actually you bring some nice news. And I have two questions. The one is about how can we get involved. And I heard from the guys outside from the booth that, of course, we can get some decommissioned Facebook servers, but that's not that easy. So could you, as the lead on the project, say a few words? Are there plans actually to be able to access the hardware, to get actual hardware that is compatible with what's in the repo? So we can just get the hardware, get the repo, and start hacking, start developing, because this is really a blocker. This is a barrier that we cannot jump over. We need to get the hardware that is currently supported. And after that, I'll ask my second question about the hackathon. Okay.
Yeah, the first question. That's a pretty good point, actually. So if somebody wants to kind of get hardware, today I think we have this hardware at Facebook that is building it, right?
Yeah, the user might.
Yeah. But the hardware that we wanted to kind of, that supported in the OpenBMC is also like multiple companies making their own contributions. Like IBM has their own servers, a couple of them, they support this OpenBMC. But there is nothing like Raspberry Pi equivalent.
No. Of course, this is a business class hardware, but still we need as a third. So we're not Google, we're not Facebook, but you want other contributors, right? So if it's a Linux Foundation project and you want contributors, you need to make a way for us to get the hardware so we can work.
There are two answers to that, actually.
There's one here, if you are happy to have something that's not x86, there are some reasonably priced
Yeah, we already got one. So we're looking, So we're looking for what can we get on the 886 side, And that's a decommissioned Facebook. But what is coming? What's more accessible?
Two different routes we are looking at it. The first one is like say giving some kind of Raspberry Pi equivalent for OpenBMC. Okay. So we are working on with the Portwell is the company that has a evaluation board that has BMCs and a COM port. So you can plug in a COM port, right off the shelf. So that gives you kind of a virtual server kind of environment where you can exercise all the BMC functionalities. So that's one option.
So there will be accessible hardware that we can just order a few $1,000s, but we can order and actually receive it.
I think it will be pretty cheap actually. I think the price point we are looking at for that particular.
Okay, because that's a barrier, You said it's a Linux Foundation project. We want others to participate, but we need to have a compatible hardware.
Sure. So that's one route we are going actually, working with these kind of companies where they can have evaluation board that supports this OpenBMC.
Sounds great.
Which is about $199 is what I think price point we are thinking. So that's one aspect. The second one is like say, how do I get access to this OCP servers itself? So we are working with the ODMs and creating a OCP marketplace. Typically, I think they build servers for the big companies, volume, like hundreds of thousands of servers. And we are asking, can they sell it to the OCP marketplace where individuals, like say students and other enthusiasts, can order like 1, 2, 3 systems. People are not at volume, but they want to kind of order. So that part is still being worked out in the OCP, but that's very active discussion right now, is how do I get access to the hardware, but not at volume, not being a Facebook, not being a Google.
Development kind of volume, development, R&D type of volume.
OCP marketplace you want to watch for. I think there is a lot of activity going on there.
That sounds great. Thanks. Sure. I'll definitely keep a close watch. And my question about the hackathon. This is a really short notice. It sounds great. A few of the topics are very interesting, but it's very short notice and it's in the US. So can you tell us maybe what's your estimate? When can we get the OpenBMC hackathon in Europe? Maybe next year, maybe this year?
I think if anybody is hosting it, I think it will be, I think it can be done. Today the problem is with the hosting. So there are companies like Facebook, I think we want to host it, but we cannot host it due to lack of space.
I can tell you there's definitely an interest, so please think about it.
And travel. So Europe, I think you want to invite all the people in US. The participation is another thing, so we need to kind of look at it. So today there are about companies in Australia and companies in Asia. They are traveling to US to kind of attend this hackathon. But it's pretty good suggestion to kind of say, if you have enough people in Europe, why don't we do it next time in Europe?
Okay, sounds great. Thanks, man.
Sure.
Given that the BMC is so tightly integrated into so many bits of the system, it really seems that this is where we need to put a lot of our trust, and it needs to be involved in our hardware root of trust. What's the OpenBMC story for TPM or other root of trust integration and attestation?
That's a great question. So we spent a lot of time, almost I would say 2 years, on making sure OpenBMC itself is verified boot because it needs a lot of hardware changes. So within Facebook OCP hardware, we added like circuit to kind of have the TPM and dual SPI flash with read-only. So to enable the verified boot on the OpenBMC itself. But again, we are not authenticating the BIOS firmware, but it's only within the BMC itself when it boots up. Is anybody hacked into BMC? So we have a kind of mechanism to kind of ensure that we are booting the right firmware, right signed firmware. But again, this is only specific to Facebook hardware. Now, talking about OpenBMC, with IBM, Google, and Intel, Microsoft, everybody has their own individual solutions for the secure boot part of it. So example is like Microsoft is looking more towards project, what is it? Sorry, I lost that. Cerberus, they're looking at that. Google has Titan to kind of make sure that third-party chip is going to do the security check before even it boots BMC or let BMC boot actually. So in our case, I think the solution we took is like a verified boot. So we have a read-only flash which has the golden image, which is not reachable, and it authenticates the read-write firmware partition and then boots there. If it fails, it will just fall back to the read-only, or the golden image. So that's the kind of security that we have today. So OpenBMC itself is, we have that as a next topic in our team to kind of discuss and see how we can have one unified mechanism across all the platforms. That's going to take a lot of challenges because of the hardware dependency with the TPM and the hardware SPI flash layout. So it's going to be challenging for us. but there is good discussion among the community. Did that answer your question? Yeah.
Okay, there are more questions?
Thanks. So you just talked about the boot time security and ensuring we boot the right firmware. Of course, part of the problem with the BMC is it has a very wide attack surface because it is connected to the host with PCI, LPC, USB, I2C, you name it. And every single of these things is an attack surface. You and I both know that there are issues in the hardware. The more long run, do we have started thinking about how we more proactively ensure that we have way to verify, test, harden all those various surfaces into the BMC, including USB gadget stack in Linux, etc., etc.?
I think security is, I would say, one of the highest priority, but always gets low priority when it comes to implementation, because of the details of how each hardware is laid out. Like as you mentioned, like PCIe is one of the easiest way to get into BMC and then corrupt or get the data from the host. So in our cases, we just disabled that part actually. So PCIe, we didn't connect it to the host at all. But the USB, for example, is a gadget device. So we communicate with USB on the between host and BMC.
Yeah, you need to make sure there is no exploitable buffer overflow in the USB gadget drivers, etc., etc. Yeah.
Yeah. So definitely, I think there is one sub-work group actually within the OpenBMC team that is kind of looking at all these surface attacks and then where we can make it more, tighten up security actually. I just give an example of verified boot and secure boot. That's just one part of it, but each of the applications have to be more secure.
A quick somewhat segue question. I've been wondering for a long time, I don't know if anybody's here has the answer, is there any reason why NCSI is limited to RMI 100 megabit and why we couldn't just spin the rev of the spec, simply allowing our GMI gigabit to be used? Because we've had all sorts of interesting issues with flow control when your management network running at gigabit and your NCSI run at 100 megabit. And things can go very, very wrong on a large scale.
But, sorry, maybe I didn't understand the question. Is it NCSI why it is not a general?
NCSI by spec can only be implemented on RMI at 100 megabit.
Right.
Is there any reason why the spec can't be amended so we can authorize running it at a gigabit on a RGMII? I've been wondering that for a long time because we have a lot of problems caused by that speed difference. Buffer bloat in the chip, flow control problems, post frames going all over the place, etc., etc.
I think that's a good question for probably DMTF.
DMTF on the spec?
Yeah, DMTF is the one that wrote the spec. And then if there is a good use case for this RGMI, I think it's easy to bring it up and see yeah, but I myself don't have the answer for that.
For experimenting with OpenBMC on x86 platform, Raptor Engineering ported it on the ASUS KGPD16, but the patch are not upstream, so I hope this helps. More information can be found on the old coreboot wiki.
Coreboot, okay.
Out of the handful of vendors that have been kept repeating here, I would classify IBM as the only real server vendor in that list. So is there any activities ongoing to get some of the traditional firmware vendors and in particular also server OEMs to sign up for OpenBMC?
That's a great question. How do we make sure this ecosystem is more healthy and invite a lot of partners into this? And then there is, our philosophy is like today we started from the service end users point of view. Like you can see the companies, Microsoft, Intel, Google, IBM. So we are all kind of getting together to see there is a need for having open source version for this BMC software. But at the same time, the companies, third-party companies, they are participating. The companies I can name already is like say the ASpeed, the company which sells this BMC chips. So they are involved in that. Nuvoton is another company, BMC, they are involved in this. Mellanox, who supplies the switch, they are in this. The other companies, they're still evaluating actually, but they're not. Dell is another company that is part of OpenBMC. HP is also, yeah. All the companies, I think pretty much like say big companies, they are there, but how to make sure this is healthy going forward? Like say down the line, like 2 years down the line, do I see this as Linux for the kernel? Do I see this OpenBMC as one place where I can go download or the source code, build my firmware? That's the vision for the entire team. But to answer your question, like the third party, the vendors, ODMs, they will join when there is a good momentum. Like a lot of people keep asking about OpenBMC on even regular servers. That's when the OEMs and ODMs will kind of jump in, and then probably they can make it happen. But again, at this time, we are like, as you can see, there are a lot of pending features that we are still working on. This is a great time to kind of have OEMs, ODMs come together and then help us.
Also partially respond to you. Couple of facts, and I'll let you put a link between them. One is, historically, open source have tended to create infrastructure, and then everybody realized that their value add is on what they put on top, and they ditch their proprietary infrastructure and use it, and then do their value add on top. Second fact is the traditional BMC software vendors are looking at OpenBMC very, very, very closely. Things may or may not happen, but the point is, it is quite possible that some people will have enough reinventing the wheel and doing GPL violations with their own BMC implementations and start building on top of OpenBMC using it as infrastructure. I don't know if it will happen, but it will be a logical step, and it will correspond to how things have happened in other markets. And we know that they are looking and asking questions and playing with it.
So could either of the two of you comment on what the current status is with regards to the model that was shown on slide 29?
You want?
So that was like this transformation about with a third-party firmware vendor to having the single repository. That was 124. Yes, with the ODMs contributing to all that. Is that already happening today, or is that still a wish for going forward?
This is in the flight today. So the ODMs, they have shown interest. There is only one ODM.
So that would be ASpeed in that case?
No, ASpeed is like BMC's SOC vendor, but we are talking about ODMs, like who build these systems.
Okay.
So one of the ODM is signed up for this OpenBMC. So,
frankly, when you are nose on the drive and trying to get your server out of the door, it's difficult. They have, even us IBM, we have our own practical tree we use to do our own builds. It's a evolutionary process. Everybody wants to get there. It's going to take time, maybe a couple of iterations of systems, we don't know. To get there. Also because we have a lot of legacy stuff running on our previous stacks that we want to move over. But it's going to take a longer time. When it comes with the BMC hardware vendors, the rule is simple, go upstream. So because it's very difficult, we try to teach them. I mean, Joel and Andrew went to Taiwan to talk to ASpeed a couple of times, tried to teach them to upstream the stuff. We rewrote half of their drivers and put them upstream. It's a classical story of ARM's SoC vendors. There is nothing new under the sun here. And again, it takes time, but we are getting there. And New Overton is starting to also upstream the stuff. So I think we are in the middle of that process.
yeah, especially previously ASpeed used to kind of give a SDK, and that's, you have to debug a lot actually. So now I think what our ask is for the next chip, they should directly contribute to the Linux instead of giving us a SDK. So the driver part of it will be kind of directly contributed to the open source kernel. So that way the quality of the drivers goes up, and then that goes through a lot of iterations. We can reuse the code. So right now what's happening is everybody gets these SDKs, all the companies, they debug independently. You know, I have the same issue, and then there is another engineer working in a different company on the exact same problem. Another 3 weeks is gone just for the same problem. So now with the OpenBMC, the idea is as you share your learnings, you get the quality up.
Okay, thank you. Unfortunately, that's it for questions. Okay. Give a round of applause for Sai Dasari.
Thank you.